out in person? Oh my gosh, that's crazy. Crazy, crazy, crazy. Okay, you guys are pulling your homework out, I'm hoping, from yesterday.
Yeah.
And I can run through the answers if you would like quickly and tell you the numbers that you should end up with, if that will help you. Let's see, some of these are going to be easy for me to just give you, I'll just kind of jot these up here. Number one, part B, looks like this. If you write it out in calculus, C is 27, D is 3, E is 9, G would be square root of 3. So listen. 2. E would be from -1 to 8. 3 and from square root of x plus 1. At this stage of the game, you guys would have had to have done number 2, part B, on your calculators. Because I haven't shown you how to do that part yet. C would be 54. D would be 9 times y. This is E, not C. E would be 6. And then G would be 3. Oops, got the parentheses on the wrong way. Number 3 on the back of this little thing has fewer questions next. Just A, B, and C. I've got 2.25 for A. I've got 0.75 for B. -2. 4 again has an A, B, and a C. 14, 14, and then cube root of 15 fourths, which is approximately 1.554. And I'm okay if you guys put the decimals, just make sure you're using 3 decimals. For A, B, and C. This should have been my definite rule, and do the answer I came up with. And the definite rule of f of x. 2g. On your way, that's okay. I just had to figure out, gotta get out of the way. This one is 2 over pi. C is inverse cosine of 2 over pi. If you guys did on your calculators, make sure you're radian mode. I got 0.8806. I would put 0.881. That worked just fine. I should probably just put 0.85. And then number 6 was the last one. And it has an A and a B and a C. I got 20 over 3, and 196 over 81, which is 2.420. Those are just quick answers for your homework from yesterday. So everybody's here except for I think we're good to go. You guys are checking your homework answers, right?
Right, 9 fourths, 3 fourths, 14, 3, 9 over 3 counts. 1.
I hear an uh-oh.
I did not get the last 2 of 5, right?
On 5. Okay. You got the part A correct though?
On number 5,
Mhm.
yes, I got it.
You got A correct, okay. So when it says find the average value, so I'm just gonna do number, oh wow, that is better.
No, I am not edit on.
You do?
No, I don't.
No, okay.
Sorry.
All right, that's okay, that's okay. Okay, so for number 5, just maybe give a little bit more, understanding on this little problem. You know what the cosine does, you know, it keeps on going and going and going, but we were told to evaluate it from 1 to 2. Now, what I want you guys to think about is that pi over 2 is about 1.57 and some stuff. So if we were supposed to evaluate this, this graph, I probably need to go, oh wait, I'm sorry, please excuse me. Combining 2 different problems, aren't I? Okay, so that doesn't make any difference. We're supposed to try to find the area underneath that. You said you had a problem with A versus B and C.
A was fine.
A was fine. Okay, so you got the area was 1.
Yes.
So we did the area, got the area as 1, and then part B says find the average value, so find the area of the rectangle.
Yeah,
It would have this same width,
yeah,
and then we have to figure out what height it should be. So this is the question, we'll call it height. So take your width, which is pi over 2, times the height, and that should equal an area of 1. How are you going to solve that for each? Divide by pi over 2, or I'm a person that just likes the,
I forgot to do,
I just do that.
was
So,
those ones,
yeah,
yeah, I totally just forgot to.
to find the h.
Yeah, to find.
Okay,
I don't
okay,
know why.
okay. So once I find
That
h,
makes sense.
am I okay, you're okay with c? Now, the answer for c, or c's, the goal for c is to find that special
yeah,
c
you
value.
Plug in the.
So you take your answer,
Yeah,
2 over pi, and you go, okay, I'm looking for cosine of x to be 2 over pi.
yeah, that's, yeah.
And so that's where I'm just putting one way of writing your answer, because you and I have talked about, you don't have to put your answer in decimal form. You could have left it like that if it had been a free response question. Or if I did it in like actual calculator form, oh, sorry, I'm looking at the wrong column. Okay, 5. This is inverse cosine of 2 over pi. You could have left your answer like that, would have been totally sufficient. Or you could actually type it in your calculator. Just make sure you guys are in radians whenever you're doing the trig stuff. Radian, 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 radian. I'll make sure that you do that before you get to May 5th, I promise. Not too many of you are in physics at the same time, but it doesn't matter. My own class doesn't take an AP test, so it won't matter to them if they're not in the right thing as much. I would remind them on any given test day. Nicely done. If you're able to get to 5 before we get a question, or if you have any others and you would like to ask, yes, ma'am.
Can you do the steps for 6?
Yeah.
6C? Okay. Now, it seems like you're telling me that A and B were okay.
Yeah.
So you got your height. Okay. So when we found in part B, the height was 20 over 3. What we need to do for C is to take the formula, which is 2 plus 3 square root of x, and set it equal to 20 over 3, because 20 over 3 is a height. It's an output value on your function. Yes, ma'am. Am I doing the wrong thing? No.
No, that's just supposed to be an
Oh, what is supposed to be an x? I'm sorry, this is supposed to be an x, yeah. I'm looking for x, right? Yes, ma'am. Okay, well, let me just do this part, and then I'll get back to the other part. Okay. Well, first off, I would say this. If you were trying to find the area for number 6, it says go from 1 to 4. You guys would have to set up the integral, and then it's 2 plus 3 square root of x dx. Now, you guys have it within your powers to be able to do the antiderivative of this. I'm going to use the purple marker that I have way down here at the end and go, okay, first of all, Alyssa, see if you agree with this. This term right here is 3x to the 1/2 power. So if I'm going to do the antiderivative of 2, do you guys remember what the antiderivative of 2 would be? 2x before. Okay. Now, then I would put plus, and I would keep the 3, because 3 is just our coefficient. Then we're going to take the antiderivative of x to the 1/2. Remember, you add 1 to your exponents. If you have 1/2 and you add 1 to it, you get 3/2. I always kind of skip a space and put 3/2 here, and then that means 2/3 would go in front. So if I wanted to do this problem by hand, I would do it this way, and then I would get that, and then I could keep on plugging and chugging. I'm okay with this specific set of problems if you guys really wanted to just do them on your calculator, but I think it's a good idea not to, because in many integrals on your test, you're not going to be using a calculator. Your calculator is usable for probably like 1/3 of the problems on the test. So I would say go with it. Do you realize that these guys cancel? The 3's cancel, right? Okay. So we have to do 2 times 4 plus 2 times 4 to the 3/2. That's me plugging in the top limit integration, and then subtracting together, we do 2 times 1 plus 2 times 1 to the 3/2 power. How am I doing so far? Okay, so I figured we'd go ahead and do this. So this is 8. And then what's 4 to the 3/2? Let's do a little review, because you definitely need to be comfortable with that arithmetic when you get your little test, you know what I'm talking about. So this, for me, I prefer to do the root first, because usually it's easier to make the number go smaller rather than bigger. So this means that you're going to square root this number, and then you're going to cube it. It also does mean, however, that you can cube it first and then square root it. You're going to get the same thing either way you do it. It doesn't matter. I just personally would prefer to square root 4 first, because I know that works. So this is really 2, right? So this, let me just do it over on this side. This is really 2 cubed, or 8. So this becomes 2 times 8. If you guys agree with what I did right here to get 8. Minus, and then it's looking like this back part is just 4. Just look over here. 1 to the, I don't care what you do, is always going to be 1, right? So the back part is just minus 4. So this looks like 8 plus 16, we know that's 24. So we subtract 4, we should get 20. So that's my answer for 6A. Is that good? That was the calculator. Now 6B, again, is just trying to find the height. So here's what we've got figured out. We know that there has to be a width times a height. Oops, if I can spell, equals 20. We know the width of this thing. This said find the interval from 1 to 4. So that's 3 units wide. Agreed? So all I need to do is just divide by 3, and then that's how I figure out my height for 3. Now, Kelly's question was, help me figure out what x is, or the c is. We call it c, but find the x that makes this become your y value. So we take this equation, and then you guys tell me what you think we should do first. This is like algebra 2 stuff. I was helping my son do stuff like this last night. Subtract 2 from both sides. So if you guys want to use a calculator, you can, or if you want to subtract 2 and just keep it in fraction form, would you agree 6/3 is subtracting 2? Okay, so we get 3 square root of x equals, I'm going with 14 over 3. How are we doing so far? Okay. Now we have to divide by 3, or my personal belief is I don't like to divide when I've already got fractions. I would rather just multiply by the reciprocal. So I end up getting 14 over 9, which isn't really great. But sometimes these are not going to be nice, easy numbers, so don't discriminate if the numbers are yucky. It just happens often, because between the interval from 1 to 4, there are a lot of numbers that are yuckier than there are that are nice, right? Now, how are you guys going to get x on one side by itself? What do you do to get rid of the root? Square it, absolutely. So if you wanted to, you guys could absolutely leave your number, 14 squared over 9 squared. 14 squared, 576. 13 squared is, no. 13 squared is 169. 196, okay. 196. And then obviously we all know that 9 squared is 81. So that's how we find it. And that's our C value. That's that special X value that gives you the height of 20 over 3. So it's really an algebra question.
Yeah, I plugged in 20 instead of the 20 over 3.
Silly thing. Then there it didn't work, so you knew what you were doing. See, that's I got it. It's in the bag. No problem, no worries here. Okay? So it seemed maybe like long and tedious, this concept yesterday, potentially. But you guys seem to be doing really well on the homework. I'm impressed. Really, especially because I didn't stick the answers on there. And you're doing, I put them up here, and you're like asking me very few questions, and you know what you're doing. That's very, very impressive. Any other questions you would like to ask about? So this week, we've done 2 big things, 2 new things. Mean value theorem for derivatives, mean value theorem for integrals. So I dug around in some of my stuff today. I promised you yesterday when we talked about it that you were like, you're probably thinking to yourself, why do we have to do this in the first place? So I went looking for as many as I could get my hands on in a quick, short amount of time. So 3 response questions where it's going to apply this exact same topic. This idea of finding the average value of the function. I found 2 of them, so I'm going to share those with you in the next few days. And when I say share those with you, that means we're going to do them, means you're going to do them, and then we'll discuss them. And also, we're going to review. The idea we want to make sure that you're okay with is that you remember the difference between the 2. Clearly you'll be able to, because one deals with area under a curve, and the other one deals with slopes of tangent lines. So nothing tricky there. All right, are we good with this then?
Yes.
All right, turn it in for me, please. Let's get you some homework grades, if you don't mind. And then the first thing we're going to do today is a little mean value theorem quiz. Now, this is not a mean value theorem quiz on, you need a stapler? It's right there, yes. Hiding in black right there. I camouflaged it. No, it's usually somewhere close by. Okay, so I have mean value theorem, so I'll trade you. I'll give you guys 2 of these. You may work on these together.
Bruce! What?
Yours was wretched.
Yeah.
I'll still understand. It's okay. You just need 1 today, not 2, right? Because yesterday
I really wrote
Thanks, Emily. I'll trade you. Thank you. Rob, you're supposed to print it and do it. Rob.
Yeah, I did.
Give me, man.
Here we go.
That's fine. You can
I did.
You did? Beautiful. Okay, awesome. Then please forgive me for acting like I was giving you a hard time. My apologies. Okay. So, your quiz right here deals with what you just did. You'll notice it says mean value theorem for intervals. Now, with our class being so small, and we're obviously down a student today, which in most cases doesn't really cut the size of the class down percentage-wise, but in our class clearly it does, because it's so small. Feel free, as you go through these, it probably won't take you any more than 10 to 15 minutes to talk amongst each other, groups share. If you guys want to go to the board and put a problem up there, go, oh, this is what I think it is.